Okay, here's a multi-step word problem involving fractions and multiplication. So let's read the problem. There were 60 runners to start a race. In the first half of the race, 2/3 of them dropped out. In the second half of the race, 1/5 of the remaining runners dropped out. So how many runners finished the race? Okay, so let's see. We have two parts to this problem, right? There's the first half of the race. So part one, let's do part one. So that's the first half of the race. We start off with 60 runners, right? And we say that 2/3 of them drop out. So how many of them drop out? Well, we take 60 and we multiply it by 2/3. Looks like it's a lot of people dropped out of that first half of the race, huh? So let's see, 3 goes into 3 one time, 3 goes into 60 20 times. So we have 40 runners drop out, right? So 40 dropped out, which means what? 60 minus 40 are left, right? Which is 20 runners left. So now this group continues on. And in the second half of the race, so this is part 2, is the second half of the race. We have 1/5 of them drop out. So out of that 20, we have 1/5 drop out, which if we do the multiplication, right, 5 goes into 5 once, 5 goes into 24 times, means 4 more drop out. So if we started with 20 in the second half, minus 4, that means we have 16 left at the end of the race. Okay, so this is the correct answer. 16 runners we have left at the end of the race. This is the correct answer, right? Correct answer is 16. Okay? Okay, now the incorrect way to do this, and some of you were wondering whether or not we could just add the fractions to begin with. So this is incorrect. All right, this is the incorrect way to do it. We cannot add the fractions first. Then multiply. So let's just see what happens when we do it, okay? So again, the two, we said we had 2/3, so we cannot do this. We cannot take 2/3 plus 1/5. Right, so that's going to give me what? Denominator of 15. So I multiply top and bottom by 5 over here. So I get 10/15, multiplied by 3 on the other one. So I get 3/15. That gives me 13/15. Right? So here I have, if I take 60 times 13/15. Right, 15 goes into 15 once, 15 goes into 64 times, and 4 times 13 is 12, is 52, right? That's going to give me an answer of 52. This is not the number of runners remaining. Okay, so this is wrong. This is the wrong way to do it. And the reason is because with the first step, we're taking a fraction of the whole, and then we're subtracting that part and making it our new whole. So let's see if I can draw a more visual representation of this. Okay, let's see. Let's say I have a block like this. Right, and I divided it into thirds because this was, say, my 60 runners. The whole thing was 60 runners, right? And I said 2/3 of it got lopped off. So that meant 2/3 of my, if each of these are 1/3, right? And 2/3 of it disappeared, right? So now this part of it, whoop, I didn't mean to do it that way. Let me draw my box back again. If I had 2/3 of it, I'm sorry, I divided my box into thirds here, and I lost 2/3 of them, right? Oops, it seems to take away my entire line. So that would mean that I have this little piece left here, right? That's my new box. Take away that. And now that becomes my 20 runners. And now I have to take away 1/5 of that. So if I divide that into fifths, that means that all I have left is this part in here, right? Because the rest of this gets lopped off too. Oops, I don't want to delete all that, but it looks like my pen's. So that's all I have left here. Right, so it's a very different problem. So if we go back to the correct way of doing it, we're not distributing the 2/3 and the 1/5 over to the total of 60. This is 60 is my first whole. This is the whole number, right? For the first part. And then my new whole becomes 20 for the second part. Okay, I hope that explained it a little bit. The difference of why you can't just add the fractions first and then multiply that by the whole. You have to do it in a two-step solution like I showed here. Okay?